Good day. For this video, we will be discussing case 2 of improper integrals. So in case 2, we have discontinuous integrand. So a discontinuous integrand is an integrand where the limits for which the interval of the limits for which the integrand is being evaluated has an infinite discontinuity. So either at the end point or in between of the interval. Okay, so when we say there is an infinite discontinuity, so the value of the integrand approaches to either positive infinity or negative infinity at the given interval. Okay, so say for example, so we have the integral of du over square root of u plus 1 from negative 1 to 7. Okay, so in this case, so we have our integrand as du over u plus 1. Okay, so our function of u here, so function of u is equal to 1 over square root of u plus 1. Okay, so that is our function. Okay, so as you can see, if we evaluate the integral, okay, so from the limits negative 1 to 7, so you can see that at u is equal to negative 1, the value of the function approaches to infinity. Okay, so if you graph this, so if you graph the function of u as 1 over square root of u plus 1, so say for example, so we have here, this is our u axis, and then this is our f of u. Okay, so getting the domain of this function, so we will have u should be greater than negative 1. So therefore, at u is equal to negative 1, so we have an asymptote, okay, for which the graph of this function will never cross that vertical asymptote. So let's say the graph looks like this. Okay, so at x is equal to negative 1, we have the value of the function approaches to infinity. Okay, so that's why this integrand, okay, so this integrand has an infinite discontinuity. So particularly, so at the end point, so this is one end point, right? So the end point of the interval from negative 1 to positive 7. So say we have here our positive 7. Okay, so at one end point, at x is equal to negative 1, there is an infinite discontinuity. Okay, right there. Okay, so in evaluating those types of integrands, so we need to specify, okay, that when evaluating the limit comes from one side. Okay, so since on the other side it is not the function is not defined on one side, then we must specify that in evaluating the limits, we consider the side, okay, for which the value of the limit is approaching. Okay, so basically that's the thing that makes it improper. Okay, so because in evaluating the limits, if you recall your differential calculus, as we approach a certain value, okay, so say for example as we approach -1, so what is the value of the function? So the limits can come on either side, from the left or from the right. Okay, but on these type of functions, we need to specify the direction. Okay, so for which the limit is coming from. Okay, so that's all. Okay, so in evaluating the integrand, so we just make use of the right hand side and the left hand side limit. Sorry. Okay, so the left hand side and the right. I think it has a dash. So left hand side and right hand side. Okay, so we need to include that. Okay, and also if we have an infinite discontinuity, so similar with infinite limits, so we'll replace this with a variable, okay, for which we will evaluate the limit as it approaches that variable, but we will be using the left hand side or the right hand side symbols for evaluating the limit. So if it's left hand side, so meaning it approaches a certain value from the left. So say for example this is a, okay, so if it's from the left hand side, so the value of a approaches to the value of the limit approaches to a from the left side. Okay, so for the right side, we have a symbol of plus. Okay, so written above the value of the limit. So say for example, so the limit of 1 over square root of x. Okay, so as x approaches to 0 from the left. Okay, so meaning, sorry, from the right, don't have a value from the left for 1 over square root of x. Okay, so from the left, so meaning for the graph of 1 over square root of x, so 1 over square root of x is, its graph looks like this, I think, something like that. Okay, so this is x is equal to 0, right? So in evaluating the limit, so we specify that the value of x approaches to 0 from the right. Okay, so this path from the right. Okay, so because this function, okay, so this function 1 over x is not defined left of x is equal to 0. Okay, so we need to include that. So therefore in this problem, so we know that -1, okay, -1 will come from the right side only, okay, and not from the left side. So that's all we need to add. Okay, so the limit of so the integral of du over square root of u plus 1 from -1 to 7. So we'll replace -1 with a letter. So the limit of the integral of let's say a to 7, so we have du over square root of u plus 1, okay, as a approaches to negative 1 from the right. Okay, so that's all. Okay, so that's all you need to add, and then evaluating it is the same process. Okay, so integrating this, so the limit of integral of, so this will become u plus 1 raised to negative 1/2, right? And then du from a to 7, a approaches to negative 1 from the right. Okay, so you must always include this in your solution when evaluating limits with infinite discontinuity. Okay, because it's the proper way to show, okay, how you evaluate the limits. Okay, so this is part of your solution. Okay, so integrating, so integral of this will become u plus 1 raised to negative 1/2 plus 1. So the limit of u plus 1 raised to negative 1/2 plus 1 over negative 1/2 plus 1, limits from a to 7 as a approaches to negative 1. Okay, so simplifying this will become u raised to 1/2 over 1/2, so that is 2. So simplifying this, so this will become 2 times u plus 1 raised to 1/2. Okay, then substituting the limit, so that will become 2 times 7 plus 1 raised to 1/2 minus, so there's a 2 minus 2 times lower limit a plus 1 raised to 1/2. Okay, as a approaches to negative 1 from the right. Okay, so this will now become, so there's no space anymore, so this will become 2 square root of 8. Square root of 8 is equal to 2 square root of 2, so therefore 2 square root of 2 times 2, we have 4 square root of 2, minus, as a approaches to negative 1, so this value approaches to 0, so minus 0. So this is our answer. Okay, so basically it's nothing new. Okay, so but it's nothing new, but what do you call this? So you are probably thinking that we can solve this without this, no? So without specifying the limit that it approaches to negative 1 from the right, no? So actually we can just solve it by substituting directly. Okay, but that is an improper way to do it. Okay, so it's improper. Also, I don't think your calculators can solve that. Okay, so if your calculators can't solve that, then it's an indefinite integral. An improper integral. Okay, so this is very, very, very important to illustrate. Okay, so where are your limits coming from? Okay, so let's have another example. For our next example, so we have the integral of 1 over cube root of 2 minus x dx from 0 to 5. Okay, so for this, our function is 1 over cube root of 2 minus x. Okay, and then our interval is from 0 to 5. Okay, so if we try to graph this, okay, so this actually has an infinite discontinuity at x is equal to positive 2. Okay, so as you can see, the denominator will become 0 if we have positive 2 as our value for x. Okay, so therefore, positive 2 is a discontinuity. Okay, so for the integral, okay, evaluating the integral, so what we need to do is we will make use of one property of the integral, so which is, if you would recall, if we have f of x dx from a to b, that is equal to the integral of f of x dx from a to c plus integral of f of x dx from c to b. Okay, so okay, so this property, so if you would recall, so this is under the properties of definite integrals. Okay, so in this interval from 0 to 5, so we see that we have a discontinuity at x is equal to 2. Okay, so we transform this, okay, into this form, okay, for which our a is 0, our b is 5, and our c will be the discontinuity. Okay, so rewriting, so the integral of 1 over cube root of 2 minus x dx from 0 to 5 is equal to the integral of 1 over cube root of 2 minus x dx from 0 to 2 plus integral of 1 over cube root of 2 minus x dx from 2 to 5. Okay, so now since this is now an endpoint, discontinuity at an endpoint, so what we're going to do is we will solve this similar with the first example, so for which we will replace the infinite discontinuity at the infinite discontinuity with a variable, and then we will replace, and then we will evaluate it using left hand side or right hand side limit. So in this case, so for the first one, so we will replace, we let that as c, so the limit of the integral of 1 over cube root of 2 minus x dx from 0 to c, provided that c approaches to positive 2. So now, since we are evaluating from 0 to 2, okay, so all the values of 2 are from the left. Okay, so 0, 1, 2. So think of it as a number line. Okay, so we are evaluating from 0 to positive 2, and then from 2 to 5. Okay, so from 0 to 2, okay, so between 0 and 2, so we approach 2, okay, from the left side. Okay, so therefore this should be like that. So the limit of this as c approaches to 2 from the left. So similarly, we do that on the other side. So limit of the integral of 1 over cube root of 2 minus x dx from 2 to 5, okay, oh sorry, from c to 5, where c approaches to positive 2, so this time from the right. Okay, okay, so evaluating now the integral for each term. So maybe we can integrate. So since this is a separate term, and then they both have the same integrand, so maybe we can integrate it indefinitely. So first, so evaluate the indefinite integral. Okay, so for the indefinite integral, so integral of, so this will become 2 minus x raised to negative 1/3 dx. So we have a missing coefficient in the differential part, so missing negative, so that we can follow the general power formula. So integral of 2 minus x raised to negative 1/3 times differential of this is negative dx. So we'll put negative here, and then we can now use the general power formula. So this will become 2 minus x raised to negative 1/3 plus 1 over negative 1/3 plus 1. So that becomes 2/3. Sorry, we have negative here, so negative. So negative 2/3. Negative 3/2. I mean. So this is negative, this is positive 2/3, and then negative, it's reciprocal, so negative 3/2. 2 minus x raised to 2/3. Okay, so for here, so therefore this will become limit of negative 3/2 2 minus x raised to 2/3 limits from 0 to c, as c approaches to positive 2 from the left, plus the limit of the same negative 3/2 2 minus x raised to 2/3 limits from c to 5, as c approaches to 2 from the right. Okay, so evaluating the limits by substituting, so this will become negative 3/2. Upper limit is, we have c, sorry, I forgot to write the limit. So limit of as c approaches to 2 from the left. So negative 3 halves times c minus x raised to 2/3. And then negative, so minus negative 3 halves, so that will be plus 3 halves, substituting 0, minus, oh sorry, this is 2 minus c, so this is 2 minus 0 raised to 2/3. Okay, so another for this one, so minus 3 halves times 2 minus 5 raised to 2/3. And then minus negative, so plus, and then write the limit of negative 2/3. So we're out of space. Okay, so 2 minus c raised to 2/3 as c approaches to 2 from the right. Okay, so evaluating this, so this one, as c approaches to 2, we'll have 0. This one, so plus 3 halves, so this will be 2 raised to 2/3, so that is cube root of 4, I think, minus, we have 3 halves, so this will become 3. Okay, so negative 3, and then squared, that is 9, so cube root of 9. Okay, so therefore we can factor out 3 halves, so times cube root of 4 minus cube root of 9. Okay, so this is now our answer. Okay, so you might think that doing this is pointless, so writing it as the limit. Okay, so because you can actually obtain the answer without using this. So but this is the proper way, okay, of evaluating integrals with infinite discontinuities. Okay, so those are the rules, and then we have to follow them. Okay, so whenever we encounter integrals with infinite discontinuities. Okay, so that's all for this video, and see you on the next videos. Good luck.